Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on analysis of discrete time systems, that is nothing but Z transform. See empathy, why do we need Z transform? For analyzing the difference equation, for stability analysis, to analyze the Fourier transform limitations and system behavior. Learners face difficulty for analyzing discrete system with feedback. Needed tool to handle difference equation. That's why we can use Z transform. Z transform simplifies the analysis, stability and system behavior from time domain Z transform analysis into frequency domain analysis. This is the why engineers use Z transform means. It is used in digital filters, control systems, signal processing and communication. For digital filters, essential tool for signal filtering and processing. It is the representation of systems used in DSP. And then control systems, discrete feedback for control system for system stability. And then signal processing, system stability and transient analysis, and also analysis of system stability and transient behavior. Communication, techniques for equalization and digital modulation. Next one, define Z transform. Z transform is used for analysis of discrete time signals. It is more broad compared to discrete time Fourier transform. It is very much useful in discrete time signals. X of n and x of z forms the Fourier transform pair. This is the unit circle representation of Z transform with respect to imaginary of Z and real of Z. The circle can be represented by unit circle that can be converted to frequency domain with the help of Z transform is nothing but j omega s by 2 to minus j omega s by 2 with respect to real of s and imaginary of s. Then types of Z transform, it can be classified into two types: unilateral or one-sided Z transform, bilateral or two-sided Z transform. Unilateral Z transform can be defined as x of z is equal to summation n is equal to 0 to infinite x of n into z bar minus n. Bilateral Z transform can be defined as x of z is equal to summation n is equal to minus infinite to plus infinite x of n into z bar minus n. And then ROC means range of values of Z where the Z transform converges. It is used to find the stability and the causality of the system. Why we are using the region of convergence means for causal systems, ROC is outside the outermost pole, and then anti-causal system, ROC is inside the innermost pole. Two-sided sequence, ROC is between the poles. ROC determines the stability and existence of the transform. This is the ideate is a transform unit circle ROC. See, it can be represented A greater than 1 means the circle represented by A, the outside the circle represented is nothing but the ROC is A greater than 1. 1 by A less than 1 means inside the unit circle it can be represented by unit. Say this is the shaded part, that is nothing but ROC. A less than 1 means outside the circle, that is nothing but outside the unit circle is nothing but your ROC. A less than 1. 1 by A greater than 1 means the both sided of the unit circle can be shaded part will be ROC of the Z transform. Next one, the imaginary of Z with respect to real of Z. X for causal system, x of n is equal to 0 for n less than 0 means it can be represented by R2. The outside the unit circle is nothing but the shaded part is nothing but ROC. Anti-causal means x of n is equal to 0 for n less than 0 means R1 should be less than 1 means the inside the circle will be the shaded part. ROC R1 less than modulus of Z less than R2 means the circle represented by first unit circle is nothing but R1, second unit circle is R2. The inside the R1 and R2 is the ROC of the region, is a transform region. Next one, x of z is equal to z divided by z minus a means the circle indicated by 1, first circle indicated by 1, the dotted line circle can be indicated by a. Greater than a means outside the a is nothing but the ROC region, right? Next one, outside the shaded part, outside 1 means this is the shaded part of the ROC region. X S of z is equal to z divided by z minus a when modulus of z should be less than a means inside the a and 1 be the shaded part, that is nothing but ROC. If it is 1 means a means the shaded part will be the one from minus a to plus a. Next one, summary of ROC in Z transform. For finite right-sided sequence means entire Z plane except Z is equal to 0. Finite left-hand sided anticausal means entire Z plane except Z is equal to infinite. Finite two-sided, that is nothing but non-causal, means entire Z plane except Z is equal to 0 and Z is equal to infinite. Infinite right-sided causal means exterior of circle of radius r1 when modulus of z should be greater than r1. Infinite left-sided anticausal means interior of circle of radius r2 when modulus of z should be less than r2. Infinite two-sided non-causal means the area between the two circles where r2 should be greater than r1 when r1 should be less than modulus of z less than r2. Next one, applications of Z transform. It is used for analysis of discrete time systems. It is used for digital signals, to solving difference equations, characterizing the transfer functions, designing the digital filter. This is the mind map of the ROC. First, we can verify the ROC and convergence of ROC. Check behavior as Z tends to infinite, Z tends to 0. And then use Z transform to find the system stability. Z transform simplifies the system analysis and design of difference equation. Identify ROC and X of Z for given X of n. Represent a digital filter difference equation in Z domain. Now we can see the assessment. Define Z transform. Z transform can be defined as X of Z is equal to summation n is equal to minus infinite to plus infinite X of n into Z power minus n. Bilateral Z transform is also called as two-sided Z transform. List the types of Z transform. It can be classified into two types: unilateral Z transform and bilateral Z transform. What is mean by ROC of Z transform? ROC is the region where the Z transform converges. It is used to find the causality and stability of the system. ROC is used to determine the causality and stability of the system. Mention the applications of Z transform. It is used in communication, digital filters, and then DSP, digital signal processing, and then to finding the difference equation in terms of discrete time signals. Thank you.